For the last sample problem under shear and moment equation, so we have here the simply supported beam na mayroong different types of loading. May moment tayo sa roller at the left support po. Then, sa gitna, meron tayong concentrated load. Then, at the right span po, from the midpoint ng beam, meron tayong uniformly distributed load or uniform load. So, here is our solution for this problem. This time, we have two segment po, A, B, and segment BC. Kaya magkakaroon tayo dito ng dalawang equation for the shear and dalawang equation naman ng moment for each segment. Kasi dalawa yung segment. For segment, okay, nakuha na ba yung reaction? So, sa reaction, ang gagawin lang natin is to take a moment at any support po. So, nag-take a moment ako at point A. So, makukuha ko una yung reaction dito sa point C. Okay? Should be point C. Then, so, yung reaction natin at C is unknown times yung moment arm niya na 10 papunta sa point A. Meron pa bang same direction with this reaction? So, wala na. Lahat na to at saka ito, same na silang moment. So, ang magiging sign natin is opposite ng sign ng reaction C. So, minus 15 for the concentrated load times the moment arm niya na 5 meters away from the point A. Then, the moment naman para dun sa uniform load. So, 5 times the length po na 5. Then, yung kanyang moment arm from point A, di ba mag-aakto dun sa kalahati ng 5 meters, which is 2.5. Then, papunta nga tayong point A. So, idadagdag pa natin yung 5 meters. Minus, may isa pang moment at point A na negative 80. So, makukompute natin class na reaction at support C equal to 34.25. Then, by getting the summation forces vertical equal to 0, so kunin lang natin yung mga vertical forces, the unknown reaction at A plus 34.25 kasi same sila ng direction, so pareho sila ng sign. Then yung ibang natitirang reaction, or I mean the natitirang vertical forces, so meron tayong concentrated load na 15 na negative 15 minus yung load, uniform load na 5, then multiply pa natin siya dun sa 5 meters para ma-convert to force na kilonewton. So ang nakuha natin is 5.75 kilonewton. Okay. Pagdating dito at segment AB, so gagamitin pa rin natin yung section para makuha natin yung mga internal shear force and the moment po along segment AB. So i-consider ko tong left side. Ito yung naging drawing natin na may boundary from 0 to 5 for segment AB. Next, to balance out our section, may isa lang tayo ditong vertical force, meaning ang magiging internal shear force is downward para ma-counteract itong reaction. Then, sa moment naman, di ba, same yung magiging ikot nito at saka nito. So, para ma-balance out, meron siyang opposite internal moment dun sa may cut section. Then, getting the summation forces vertical para makuha po yung shear equation. So, meron tayong 5.75. Then, vertical minus V. Then, transpose lang natin. Mag-equate yung V natin or internal V natin ng 5.75 kilonewton. Then, yung moment naman along segment AB. So, kunin lang natin yung moment. So, we have a clockwise direction ng moment at point A, 80. Then, ito, papunta dito. Clockwise din siya. Same siya ng rotation. So, 5.75 times yung moment arm niya na X. Then, yung ika-counter siya ng internal moment minus M. Then, we got this equation for moment po. Pagkatapos nyan is, i-consider naman natin yung segment BC. This time, dito na yung magiging section natin. From the left, papunta dito sa cutting section. Meaning, ang X natin, magsisimula from the left, papunta dun sa kung saan nag-cut tayo at segment BC. So, ito yung naging drawing natin, where yung magiging boundary ng X for segment BC, kasi ito lang yung segment BC, is 5 meters, ito from left, di ba? Ang point B is 5 meters. Then, yung point C naman, from left, is 10 meters. So, yung magiging boundary ng segment BC is 5 to 10 meters. Then, copy lang natin yung mga natitirang forces and moment. So, we have 5.75, then moment 80, meron pa tayong concentrated load, 15 kilonewton, then uniform load na 5 kilonewton. So, So, ito yung segment BC. Then, para sa shear po, to counteract these forces, these vertical forces. Okay? So, yung assumption natin, again, positive shear siya and positive moment. So, yung makukuha nating vertical forces equal to 0. So, 5.75 minus 15, kasi opposite na siya ng direction nung sa reaction 5.75. Then, lahat na to is negative na. Minus the uniform load na 5 kilonewton per meter. Then, yung length naman nitong uniform load natin. So, from left support, papunta po dun sa cut section, may distance x po siya. Yung kailangan lang natin is itong length nung uniform load. So, yung x natin, isubtract lang yung 5. Ang matitira is ito. So, x minus 5. Then, minus v equal to 0. So, ayusin lang yung equation natin. So, transposing it to the other side and combining the constant number. So, makukuha natin itong shear equation. Then, for the moment naman po, so, magte-take a moment tayo dun sa cut section. So, 5.75 times yung distance x niya papunta sa cut section plus the moment po, 80. So, wala na yung moment arm kasi as is na siyang moment. Minus itong mga opposite ng rotation dito sa dalawa. Kaya negative na siya. 15 times yung moment arm niya na x minus 5. Ito yung matitira. Then, yung uniform load natin, 5 times yung length dito na x minus 5. Then, yung kanyang moment arm po na mag-act dun sa center nitong distance, which is kalahati ng x minus 5 over 2. Which is kalahati ng x minus 5. Or x minus 5 all over 2. Then, ito, same pa rin yung direction nitong tatlo. So, minus m equal to 0. So, lahat nung parehong direction dito, negative po yung sign natin kasi opposite siya nitong ikot ng dalawa. So, ito na yung magiging equation natin for the moment. So, ang ginawa lang is, inayos lang natin, no? So, kinopya to, ito din, then ito, and ito, inayos lang natin since pwede natin to i-combine, then finactor out lang natin o nilabas yung 2, so 5 over 2, then, di ba, magkamukha lang sila, so mag-squared lang sila, x minus 5 squared. Then, to draw the shear moment diagram, for segment AB po, ang magiging reference natin for the shear is hanggang dito lang for segment AB. For point A, so papalitan natin yung x equal to 0. Pero dito sa segment AB, yung na-establish po na shear force, walang x na kailangan palitan ng 0. Meaning, all throughout this segment AB po, ang kanyang shear force is 5.75. Okay? Then, at point B, so, ganun pa din, papalitan mo yung x mo equal to 0. Pero since wala nga dyan x, yung point B mo equal pa rin siya sa 5.75. Then, connecting the 2 points. So, even po yung shear natin for this segment. Then, pagdating sa segment BC, dito tayo magre-refer for the shear equation where yung boundary ng x is from 5 meters to 10 meters, no? 5 to 10. Then, ito yung nakuha natin class na shear equation. This time, yung x natin at point B is equal to 5 po. Papalitan lang natin ng 5 yung mga x dito. So, 5 minus 5 magiging 0. Yung matitira dito is negative 9.25. Negative siya, so bababa siya ng negative 9.25. Then, sa point C naman, yung distance niya from left is 10 meters. So, papalitan mo lang yung x dito ng 10. Yung na-compute natin is ito. Therefore, yung naging result niya is negative 34.25. Then, syempre, di ba merong upward na reaction? So, tataas siya ng 34.25. Then, babalik siya pa rin sa equilibrium. Then for connecting the 2 points po, kung makita nyo, it is a uniform load. So, straight line lang yan. So, simply connect the 2 points linearly. So, straight line lang siya. Next, for the moment naman po, ito yung segment AB. So, titingnan nyo yung moment equation for segment AB. Papalitan lang natin yung point A at x equal to 0. So, ito papalitan natin ng 0. So, ang matitira is 80, positive 80 pataas. Then, pagdating sa point B, yung x natin at point B is 5 meters. So, papalitan lang natin to ng 5. So, yung na-compute natin is 108.75. So, sa pagkukonect po ng dalawang points, parang dito na kayo titingin dun sa shear diagram. Kamukha lang siya ng concept dito sa loading diagram, where pagka mga uniform load, linear lang po siya or straight line or. So, straight line lang din yan. Then, pagdating naman sa point C, di ba? Meron tayong segment BC. Okay, may segment BC tayo. So, ito yung magiging equation natin, moment equation for segment BC. Papalitan lang again natin ng 5 yung x dito for segment BC. Kasi nga, yung boundary niya is 5 to 10. So, palitan mo lang. Ito na yung B prime na equal pa rin siya sa 108.75. So, magkapareho lang ito dito. Kasi wala namang internal moment para mag-change pa yung moment dito at this point. Then, at point C, this time yung x mo, papalitan mo lang ng 10 dito. So, yung nakuha natin, yan, palitan mo lang ng 10, yung mga x dyan, at point C. Ito yung moment at point C, na nag-equate po sa 0. So, tama na, moment dito is 0, kasi wala naman talagang moment na makikita based dito sa figure natin na hinge, no? So, 0. Then, sa pag-connect naman nitong dalawang point, di ba, hindi na to rectangle. So, trapezoid po siya. So, meron siyang maximum intensity dito, banda. So, meaning, nag-i-increase yung slope. So, pag nag-draw ka ng tangent line, so nandito yung pinaka-maximum slope, yung may mataas na slope. Kasi ito yung may maximum na height. So, magiging ganito yung drawing ng curvature natin at second degree. Okay? So, ito na yung solution natin.